talking about the constant speed prop on a complex aircraft. So, the first thing we're going to do, we're going to look at this very complicated picture, but we're not getting scared because it's actually a very simple process. But first, I want to tell you about a little backstory and why this piece of machinery is so useful, so reliable. So, one time I was coming back from my commercial check ride, coming out of 14,000 feet, and in my descent, because of how the system operates, I didn't have to make a power reduction because of how the system works, and I'll get into that in a second. So I was able to come down at a much faster speed, decreasing my en route time and decreasing the amount of fuel I burn. So that's all things that we look for as pilots, and that's why a lot of pilots prefer this system over a fixed pitch prop. So the first thing I want to go over is the governor. So the governor is these three pieces right here. So the flyweights, the speeder spring, and the theta shaft. So the flyweights, I want you to imagine them as like a field goal. And you invite Jackie Chan over and he gets too excited, he chops that field goal in half and it goes like that. The field goal splits in half. Now what happens, let me scroll down. Now what happens when the flyweights go out like this, the speeder spring reduces pressure and it pulls what we call right here the pilot valve. It pulls the pilot valve up and it allows oil pressure coming from the engine to go into the prop hub, pushing this piston, which in turn turns and rotates the prop. Now why do we want to do that? So in takeoff setting, the pitch of the propeller is set for low pitch, so we don't have as big of a bite of the air. So we can get maximum RPMs out of our engine. So when this happens, when oil goes into the prop hub and pushes this piston back, the prop angle changes and it increases. So as the prop's turning, it gets a bigger bite of the air, slowing the RPMs of the engine down. Hence the name, the constant speed prop. So when we initiate a descent, and we have 2300 RPM set, this is going to add more oil into the prop hub to get a bigger bite of the air, making it harder for the prop to turn, allowing it to slow the RPM down to maintain that constant RPM. So it works the same way going the other direction. So, alright, so Jackie Chan, he broke our field goal, so boo-hoo. So we hired a guy to fix the field goal, but he kind of had a lazy eye and he didn't know what he was doing, so it's kind of crooked like this, so it's pointed in like this now, so our field goal's kind of jacked up. So what happens when this occurs, so the flyweights are going to go in just like that, the speeder spring increases tension, pushing the pilot valve down, and what this allows is it allows the oil to come out of the prop hub. So first, okay, so this spring right here will push the piston out, pushing the oil out, going back to the oil sump, back into the engine system. So what that does is we go from a high pitch, low RPM setting, so a cruise setting, to a low pitch, high RPM setting. So like if we were to lose our engine, if we were to lose oil pressure, we would, so that would happen. All the oil pressure would go out, and that right there would happen. The spring would push up, and we go to low pitch because that's what we want in a glide scenario. So so why people like the constant speed prop over a fixed pitch? So in my story, I told you about how I was coming down and I didn't have to adjust my power setting. So we don't have a whole lot of overspeed problems. That's what we have in a fixed pitch, and I'll get to that in a second. So, like again, I initiated the descent, didn't have to shoot with the power because of the blade angle pitch change. It went to a higher angle of attack on the blade, and it caused me to not have to have that pitch change because it was taking a bigger bite of the air, making it harder for the engine to turn that prop. So, and the reason an overspeed happens in a fixed pitch is because when you initiate the descent, that prop angle is set by the manufacturer. So when you initiate a descent, that prop's going to speed up and your RPMs are going to increase. So that's why we have to normally reduce power on a fixed pitch prop when we initiate a descent, because of that overspeeding issue. And that's why a lot of pilots really prefer the constant speed prop over the fixed pitch. Now, again, with the constant speed prop, it is a little bit more expensive to maintain. That's why a lot of guys only use fixed pitch, because it's cheap, simple, a simple system. This is obviously has a lot more moving parts than a fixed pitch, because it's direct drive from the engine, from the crankshaft. So it's just a couple little pieces, and this is a lot of moving parts, moving very, very fast. So, yeah, so that's really a basic understanding of how a constant speed prop works. And, yeah, that's it.